Okay, this is going to be the stats lesson for Algebra 2, lesson 1 on a mean, median, standard deviation. Okay, what we're going to do is we're going to use this for Desmos. Okay, we're going to put this into Desmos. All right, what you do, okay, is you load your, you can go to functions and scroll down and you can find these things that say mean, median, standard deviation, but you type mean and then you just type the numbers. 17, 28, 23, 42, 31, 19, 39, and then 28. Okay, so it says Jason Tatum's points scored in the last 10 games. Here is the mean. Okay, basically what the mean is adding everything up and dividing by how many there are. Okay. All right, so my mean is 26.6. Okay, to get the median, okay, all you got to do, okay, right, just click down here and then just replace this word. Okay, just delete it, and then go to functions and go back and just put median. Okay, and then just delete the parenthesis. Okay, and that's 26.5. Standard deviation. What standard deviation does is talks about consistency. Okay? All right. So what I'm going to do is go ahead and delete that. Functions, scroll down. Okay. All right, standard deviation right here. Okay, once again, delete that. 9.05. Okay? Now, it says Jalen Brunson scored in the last 10 games. We're going to go ahead and find the mean, which is the average, the median, which is the middle, okay, high to low, okay, etc. Okay, so what I'm going to do is I'm going to delete this. All right, I'm going to go ahead and type functions since we're doing mean. Let's go ahead and put that in there. All right, and then I'm going to start typing the numbers. 29, 31, 25, 33, 22, 34, 25, 28, 30, 24. Okay, 28.1. Okay, to get the median, okay, just click down here, delete mean. Let's go ahead and delete mean. Just go ahead and put median. This saves you a lot of time. And then just delete that parenthesis. 28.5. Standard deviation. We'll go ahead and delete that. Functions. Standard deviation. Okay, go ahead and delete that. 4.01. Okay, all right. So based on the previous problem, who had the higher average? Okay, well, that's going to be Brunson. Okay, who is the most consistent? Now, how do you tell that? Look at the standard deviation. The lower number, the more consistent. So that's also going to be Brunson. Okay, all right. All right, so lower standard deviation, the lower the deviation, the more consistent. Okay, all right, let's go to the next thing. Scores on the math test, okay, all right. What I'd like you to do is pause your video and go ahead and find that, okay, all right. I'm going to do that real quick. Functions, mean, okay, 84, 82, 88, 32, 79, 91, 92, 85, 84, 96. All right, 78.3, and then the standard deviation. Okay, I'm going to click down here, then click over. Let's go ahead and delete that. Functions. Standard deviation. Okay, 27.28. Okay, now, that's pretty high in consistency, and here's why. If you look at that 32, that's the reason. That's the big gap. If you remove the lowest one, which is that 32, okay, so, all right, if I click in there, oops, sorry, that should have been 32. Apologize. Let's go back and do that again. Sorry, that was not correct. I typed the wrong thing. Sorry. Standard deviation is 18.05. I thought that was a lot. Okay, let's go back and find the mean. Okay, we'll delete that. Functions. Mean. 81.3. Okay, now, if I were to delete the 32, watch what happens. I go to 86.7. What's the new standard deviation? Okay, let's go ahead and delete that. Standard deviation. Okay, 5.403. Okay, what's the difference in the mean? Well, let's just go subtract those numbers. 86.7 minus 81.3. Okay, 5.4. Okay, what's the difference in the standard deviation? 18.05 and 5.40. Okay, 12.65. Okay, all right. So by removing that lowest score, you got more consistency. Okay, all right. Car sales for the week. Somebody sold this. The salesman has only 1 day left to sell cars, wants to have an average of 3 cars per day. How much does he need to sell on that day? Okay, so here's the average. Here's how you do mean. Mean is the total number is your total divided by how many number of items you have, or items or total count. That equals the mean. Okay, all right. Now, how do you figure that out? Okay, well, currently I have 1, 2, 3, 4, 5, 6. So if I have one more day here, I'm going to have 7. Okay, all right. Now, I want a mean of 3. Okay, so here's where my total has to be. So what I'm going to do is I'm going to cross multiply that up. So 7 times 3 is 21. So my total has to equal 21. All right. Well, what do I have so far? 3 plus 4 plus 0 plus 1 plus 5 plus 4. I have 17. So my current total is 17. What would I need to do to get to 21? Well, that's going to be 4. Okay. All right. Now you could do it this way. You could total these up and have you have 17 plus the extra day. There's a lot of different ways you can do it, but that's what we're doing there. Okay. So here's what I'd like you to try on your own. This problem. All right. Now let's talk about z-score. All right. Z-score is in reference to standard deviation, and there is a formula that I will give you that says z-score equals x minus this over this. Now, what this means, this is your standard deviation. Okay? This is your standard deviation. This is your mean. Obviously, the z stands for z-score. Okay? All right? So, what I would do there, okay, what is the z-score for 165? And this right here is your item that you're putting in. So my z-score for 165, I got 165 minus the mean, okay, divided by the standard deviation, okay? Now, this is really easy. All I got to do, 165 minus 200, that's negative 35 divided by 30. My z-score is negative 1.16. Now, the reason why it's negative is it's less than the mean, okay? All right, we'll go over that later with the normal curve. What is the z-score at 240? So 240 is bigger than the mean, so we're going to expect that to be positive. Okay, so 240 minus 200 is 40. 40 divided by 30, it's going to be a decimal. That's 1.3. Okay? 1.33. Okay? All right? If the z-score is 22.6, what was the amount for the flight? Okay? Well, if my z-score is positive, I expect that flight to be more than the average. Okay? So I got 2.6 equals x minus my mean and my standard deviation. Now, what I'm going to do, I'm going to cross multiply that up. All right? I'm just going to refresh this real quick. 2.6 times 30. Okay, 78 equals x minus 200. And I would just add 200 over here. Okay, so that's going to be $278. And that's what it should be because it's positive z-score. If it's negative z-score, what am I expecting? A number less than the mean. Okay, same deal. I'm going to cross multiply that. Negative 1.5 times 30. That's negative 45 equals x minus 200. Add 200. Okay, that's going to be 155 for x, which is that's what I expect because it's less than the mean. Okay, you guys go ahead and try these problems. Okay, now let's talk about a normal curve. Okay, everything in statistics. Okay, SAT scores, large sample populations, they follow what they call a bell curve. Okay, you'll hear sometimes people say they score a test by curving it. Okay, now here is the idea. In the middle of the bell curve is the mean. This is going to be the positive. This is going to be the negative, meaning above the mean or below the mean. Okay, now here is the concept. Okay, I've got a mean of 200. Okay, standard deviation, we talked about that, involves consistency. So when it says plus and minus standard deviation, we're going to do 1 positive, 2 positive, 2 negative. I'm sorry, 3 positive. Okay? All right? And then going the other way, it's negative 1. All right? Negative 2 standard deviations and negative 3 standard deviations. So what does that mean? If it's 200 and they're telling me my standard deviation is 30, this number here would be at 230. Then I add another 30, 260. Then I add another 30, 290. When I go the other way, I subtract 30. Okay? So basically, it's plus and minus the deviation. That's how you figure it out. Okay? So then it's 140 and then 110. Now, what does this mean? This is most of your information in the normal curve takes place in those first standard deviations, about 68%. Okay? That's the idea. Okay? So, 110. Okay? So the idea between plus and minus 1 standard deviation is about 68%. Between 2 standard deviations, about 95%. And then between 3 standard deviations is 99%, approximately. Okay? So most of your data is around the mean. Okay? Then a huge amount of the data, almost all, is within 2 standard deviations. Almost everybody, but a little bit, is within 3. Okay? So all we're doing in this lesson is making the curve. It says the mean for a dinner at a restaurant for 2 people is $60 with a standard deviation of $5. Draw a normal curve. Okay? All right? Well, if I got the mean is going to be 60. This is 1 standard deviation, 2 positive, 3 negative, 3 positive. Then I got negative 1 standard deviation, negative 2 standard deviations, negative 3. Now, what does that mean? If my standard deviation is 5, this would be 65, this would be 70, this would be 75. Going the other way would be 55, 50, and 45. Okay? In the next video, we'll talk about how to actually calculate this stuff. Okay? What I would like you guys to do is go ahead and draw your normal curve and label your standard deviations.